Hello everyone, welcome to Pep Coding. So in this video, we are going to start the next question of our tree series. And the question that we have this time is lowest common ancestor of a binary tree. Okay, so we already have solved this kind of question in our level 1. Okay, but this time let us see what we are going to do different in this question. So as you remember, what is LCA? So if I talk about LCA, okay, then in simple one line, if I say, then it is first intersection point. First intersection point of two nodes. Okay, first intersection point of two nodes. Suppose if someone is saying that give me the LCA of 4 and 7. Okay, give me the LCA of 4 and 7, this and this. You have to find the LCA of this. So what will be the LCA of this? I'll say this one because this is the first intersection point of this and this node. Okay, these two nodes are intersecting at 6, right? So this is LCA. So 6 is LCA. 6 is LCA for 4 and 7. Okay, 4 and 7, 6 is LCA. Now let us see some other cases. We'll see some other cases. That is, suppose we have to find LCA of 4 and 14. Let's say 4 and 14. Then what will be the LCA? See, first intersection point will go up. This will also go up. So this is the point where these two lines are intersecting, right? These two nodes line are intersecting. So this is the point. So 8 is LCA for 4 and 14. Okay, so this is it. And what else? Let us see what else we can do. So one more thing is suppose we have to find LCA of 10 and 13. So what will be the LCA of these two? I'm saying the first intersection point. So if I'll go up from this line, that this node itself is the first intersection point of this node and this node 13. So in this case we will say 10 is the intersection point. 10 is LCA for 13 and 10. Okay, for 13 and 10, only 10 is the LCA. Now some other cases. Is there some other case? I think we have covered all, and let us see how we can do this. Okay, let us see how we can do this. First of all, I want to tell you that in this question we are going to use no extra space. No extra space apart from recursion space. Okay, no extra space apart from recursion. We'll just take the help of recursion, and we'll just take the recursion space, and will not take help of any other function, like will not use root to node path here. Let us see one method from which we can do it, and that method is root to node path. Suppose we have to find LCA of any two numbers. Suppose let's say 6 and 10. Okay, we have to find LCA of 6 and 10. So what we used to do, first of all, we have this node to root path. Okay, we find the node to root path of these two. Okay, so let us say the node to root path is, okay, first of all let me make this completely. So it would be like this and this. Okay, so what will be the node to root path for 6 3 8? It will be 6 3 8, right? Node to root path, that means 6 then 3 and then 8, right? And for 10 it is 10 and 8, right? It is 10 and 8. So if we try to see from the last, then this is equal, right? This is equal. And 310 are unequal. Okay, so these two are equal. That means it is my possible LCA, right? Because these are intersecting here. Equal means these are intersecting here. Okay, these are intersecting. This example is not actually, I can say this example is not enough to understand, but we'll take the help of some other example also. Okay, so we have 8 8 8 8 is the possible LCA, right? 8 is common in this, 8 is also common in this. So what I told you, LCA is first intersection. That means first intersection means the first time, or I can say from above we can say the last time they are intersecting. Okay, suppose we have to find the intersection of I mean the LCA of, so here we can see first of all in this 8 is LCA. Okay, why 8 is LCA? Because after this we can see that these two, it is 3, it is 10, these two are becoming different. That means this is going somewhere else and this one is also going somewhere else. So this is the point where these are common. So this is LCA. Okay, this is LCA. So that is why I'm saying that it is LCA. And let us see some other example. And that example will be suppose let me increase some test case. That is, suppose here we have 15. Okay, and here we have 15 and here we have 10. Okay, 10 is already there, so we'll take 19. Okay, and we'll take 30. Okay, these are some values. So if I'll take node to root path of this one, okay, so then that would be 30, then 19. Okay, and 30, 19, then 14, then 10, and then 8. Okay, and if I'll take node to root path of this one, then that would be 15, 13. Okay, and then after that we'll have 14, we'll have 10, we'll have 8. So these two are equal, right? So these two are equal. This would be my possible LCA. So I'll go up. I'll go to the left side, right? I'll go to the left side because it is my node to root path. So I try to reach to my node from my root. So here is my root. 8 is my root. The first element is root. I mean the last element is my root. So I'll try to go to my node. Okay. So when I'll go to my node, I'll see that if the next elements are equal, these two are also equal, then it means that this is my this is my more probable I can say. Okay, more probable LCA. Okay, this is my more probable LCA. That means these two are equal. That means suppose it was like this. These two are going in the same line. Here these two are going in the same line. So it is also going in the same line. It is also in the same line. Okay, and these two are not separated yet. So these two are not separated yet. Then what it is saying? It is saying that when these two are not separated, then it means that they are going in the same line and they are not yet intersected. Okay, they have not yet chosen their different path, so there is no intersection point yet. They are going in a collinear way. That means in the same line. They are going in the same line in a collinear way. Okay, so this is just a probable LCA. Okay, not the perfect LCA or not the exact LCA. This is just a probable LCA. Okay, so 10 is my more probable LCA. Okay, and now 14 and 14, these two are also equal. So okay, I keep my I here, I keep my j here. First of all, my ij were there, both are equal. I did I minus minus j minus minus, went to this one. Okay, again these two are equal. I did my I minus minus j minus minus, then ij are here. Okay, 14 and 14. So I'll say these two are my more probable LC. Okay, these two are my more probable LC. Okay, now 14 and 14, again these are that means again these are in the same line, and I have to find that if it is the LC or not. How I can do that? I'll again do I minus minus and j minus minus. Okay, so my ij are again here at 19 and 13. Okay, now I see that now these two are not equal. Now these two have part their ways. So the last element that was common in between both of them. Okay, the last element that was common was the LCA, because LCA is the lowest common ancestor. Lowest means which will come in the end. Common means which will come in both the paths. Okay, and ancestor means a child which is coming. Suppose an ancestor of 13 are, if I talk about ancestor of 13, then ancestor of 13 are 13 itself, then 14, then and 8. Okay, so and ancestor of 7s are 7, then 6, then 3, and then 8. Okay, 8. So what is the lowest common ancestor? It is the ancestor, but it is not coming in the lowest area. Okay, lowest area means in the end. Okay, so it is not the LCA. Is it the LCA? Okay, it is the LCA because it is coming it is the lowest common ancestor. No ancestor is common after that, right? No ancestor is common after that. 10 and 3 are not equal, 14 and 6 are not equal, so it is the lowest common ancestor. Because okay, we will first of all we will say this probable. Okay, first of all we will say it is probable LCA, and then when we are sure about it, we will check that if next are unequal. If next elements are unequal, then that means that the probable was surely the LCA, right? Why they were surely the LCA? Because that was the last point where it was intersecting. That was the last point where it was intersecting. So this is why it was my LCA. Okay, so this was the theory of LCA. Okay, this was just the theory of LCA, and the previous method that we used to do, that is with the help of node to root path. Okay, with the help of node to root. That was that. Okay, now we are going to use recursion, and will not use any extra space, like will not use any array list or something. Okay, so how we can do that? So as I told you, I'll take the help of recursion. Okay, so I'll try to tell you this with the help of a recursion stack. Okay, so this will be my recursion stack. So first of all, I'll take 3 variables. Okay, that is my what these 3 variables will signify, I'll tell you. And that 3 variables will be, okay, once I'll just complete this stack. So my 3 variables will be, see, I'll say if I am LCA. Okay, I mean if I am equal, that means self present. If LCA is present on me, okay, and right present. If LCA is present in my right, that means if nodes are present in my right. Okay, LCA means nodes are present in my right. And if left present, if nodes are present in my left. Suppose if a node is saying that a node is present on my left and one node is present on my right. Okay, it is saying one node is present on my left and one node is present on my right. So it is saying that I am the point where these two are separating, that I am the common point. I am the common point for them. Then it means it is saying I am LCA, right? I am LCA. Now, next example. I hope that you got that I'll take help of 3 variables. That means self, what I should say this, it is self present, I can say. Okay, self present, left present and right present. Okay, self present, left present and right present. We'll say this: self present, left present and right present. So what I will do, I'll simply try, if I'll say if my node, suppose if my node, I'll take LCA of we'll take an example, and I'll take LCA of 3 and 4. Okay, 3 and 4. So 3 will say that I am equals to my self done. I mean my self present. My self present is saying that I am equals to this 3, right? I am equals to this number, this node. Okay, so I am the possible point where they can meet. Okay, how it will be sure? It will be sure when it will say, see, 3 will also say that 4 is present on my right. 4 is present on my right. 4 is present on my right and I am 3. 4 is present on my right and I am 3. So it means it is saying that it is like this: 4, 3. Okay, 4 is on the right and I am the 3. So I am the point where these two are becoming common, right? I am the point where these two are becoming common. So see, one more thing. Suppose 1 is 3. Okay, node is 3 and we are again saying help of 8 and 9. Okay, let us say 8 and 9. So what we will do, we'll find if 8 is present on my right, 8 is present on my left, 8 is present on my left. Okay, it is saying true, it is left true. Okay, it is saying left present, and it is saying right present. So when it is saying something is present on my left and something is present on my right, then it is saying that it is the point where there are 2 nodes present on either side of them. Okay, one is this side and one is present on this side. Okay, so that means this is the point where these two are separating their way, and this is the point which is the last common point. That means it is the lowest common ancestor of them. Okay, so this will be the LCA. 3 will be the LCA. Okay, so let us do a dry run, and this will make us clear about this technique and this LCA. Okay, so let us do a dry run. So what I'll do in my stack, as I'm taking 3 variables, so first of all I'll have 3 empty spaces here. Okay, and in them I'll write something, and what that would be, I'll first of all traverse in it. Okay, I'll first of all traverse in it. So it will go to its left and will say my self present is false. Okay, my self present is false, that I am not equals to. Okay, first of all let us take let us take 2 numbers for which we are calculating the LCA, and 2 numbers will be, suppose suppose I'm saying 4 and 7. Okay, 4 and 7, for them we are taking our LCA. Okay, so let us do it. So now here it is saying my self, it is my self present, it is my left present, it is my right present. Okay, so self present is false, so it will go to its left. Now 3 will go to its left and will say my left present is false, my self present is false. Okay, and also these two are blank here. Okay, now I'll go to 1 and 1 will go to left and will say my self present is false, you have left present and right present. Okay, so 1 will go to the left and will say I am not present in my left. Okay, nothing is present on my left, so it will return false from the left. Okay, and similarly from the right, 1 will say it is false. Okay, so nothing will be returned from this, so it will return here false, right? So false will be returned to this. Oh, let us erase it. It is done with both the calls. So now when I'll reach here, I'll reach 3 left, right? 3 left is done, and 3 will go to its right, but from left 3 gave me false. Okay, from here 3 returned false, so it has false in this, right? So now it will go for the right call. Now when it will go to the right call, then it will reach to 6, and 6 will make its left call. Now we are calculating for 4 and 7, right? So is that equals to 4 or 7? 6 is equals to 4. No, self done is not false, it is false, and these two are blank, right? So 6 will go to its left, so in left we have 4. Okay, and after 4 we have to go to left, and in this, but in this time we get true here. Why we get true here? Because it is equals to that number which for which we are finding the LCA. Okay, that is equals to the number for which we are finding the LCA, so it will give me self present true, right? So it is itself equals to the number, so it is giving me self present true. Okay, so I'll go to my right. From here. Okay, right will give me false, and then left gave me left gave me false, right gave me false, but I'll return true from here. That it is present in my one side, right? So what I'll do, it is done with both of its call. So okay, so 6, it will give true to 6, right? So it will give true to 6, that is left present, true to 6. Now 6 is done with the left call, 6 will go to its right. Now it will say 7. Okay, it will reach 7 and will ask 7 to go to left, but 7 will say I'm true, and these two will be empty. Okay, now 7 will go to left and return false from there, because left there is nothing in the left. So 6 will go to right and again return false from there. So when it will be done with this, because 7 has already returned 1 true, right? 7 has already returned 1 true, so it will tell this one that I have a true. Okay, so 7 will come out of the stack. 7 will come out of the stack, and this will give us true. Okay, and at this node, see, at this node what it is saying, it is saying that 6 is a node where there is left is true and there is right is true. So that means there is something in the left of it, there is something in the right of it. So will is it not the LCA? It is the LCA. Why? Because it is the last common point where these two are separating their ways, right? These two are going, one is going to the right of it, one is going to the left of it. That means left is true, right is true. Okay, something is present on its left, something is present on its right. So we'll take a static or global variable of LCA. Okay, we'll take a static or global variable of LCA and we'll store this 6 in that LCA variable. Okay, we'll store this 6 in that LCA, and then after that we'll return when we'll get LCA. At that point we'll return from here we'll also return, and finally we'll return that LCA. Okay, or finally we'll return true because we found that LCA. When we found that LCA, we'll return true. Okay, and at the end we'll print this LCA. Now one more example, that is, I want to tell you something after this 4. So when we'll reach 4, I'll tell you something. Okay, so here at this point what we got? 4. Here we have 4, right? So 4 is saying that I'm self present is true and these two are blank. Suppose 4 is saying go to my left, right? So suppose here we have 13, here we have 11, and here we have 12. Self is present, no. So it is okay. Okay, so I hope it is okay. Okay, 13 is present, so we'll take 19. Okay, because in this tree we have some constraints, that is C. The number of nodes is this range. Okay, and all nodes are unique, so that is why I'm taking the unique values, and P is not equals to Q. Okay, and P is not equals to K. And one more thing, P and Q may or may not exist in that array. It might be possible that both are not present or both are present. Okay, it might be true. So for that you have to handle the cases. So how we will do that, we will see. But first let us move back to this. Okay, now we have this 19 here and this 12 here and this 11 here, right? So 4 is saying go to my left, so it will go to 19. Okay, and we'll check if 19 is equals to the number, that is 4 or 7. No, it is not. So it will again say go to my left. Okay, so self is false here. Okay, self 1 is false here, and it will say go to my left, so left will also return the false here. Okay, it will go to say go to my right, so right is blank right now. But from here we'll reach 12 will say to go to my left, so self is false. Okay, left is also false, it will go to right, so right will also return the false. So finally it will return false, right? Finally it will return false, so it will be popped out of the stack and it will reach to 19. When it will reach to 19, then at that point it has returned false, right? So it will also return false. So it will also return false. That means it will say that, and it will return false to its left, right? So it will say left was false, nothing was present on that. So now 14 will say go to my right, so right will also return the false, right? Because there is nothing on the right, so this will also return the false. So it is also false, right is also false. And finally when it will reach to 6, so as it has one value true, so it will finally return true because there is one value present in the left of 6. So to the 6 it will return a true because it has found a value. Okay, so it will return true to this, that is to its left it will return a true. So let me write it. Okay, let me write it. So this will be popped out, right? This will be popped out and this will return a true to this. So this will return a true to this, and 6 is done with its left, so 6 will go to right, right? 6 will go to right, and when 6 will go to right, so it will be 7, and 7 will go to the left. Okay, and when 7 will go to the left, then it will say C, self is equals to that. Yes, it will say true. Okay, and left and right are still blank. Okay, so 7 will go to its left, will return nothing, so self will return false from the left. 7 will go to right now, So when 7 will go to right, it will say it has 11s. Okay, once I go to my left, it is saying that false. Okay, for self it is saying false, for left it is saying false, and it will go to right, it will say again false. Okay, so it is done with false, 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 so it will return false to this, it will return false to this, so it will return false to the right of 7, so it has false. Okay, it has false. Now it will be popped out, but this has returned false to 7. Okay, this has returned false to 7. So in the right of 7 we'll have false, false, and self of 7 is true. Okay, so when this will return, when 7 will return to 6, then it will say I have one true, I have one true, so I'll say my answer is true. Okay, I have one true, so my answer is true. Okay, now when it will return its answer, then it will be out of the stack, and then after that it has returned its value to 6, and it is saying that I have returned true. And when 6 is checking that it has true, that means something is present on my left, something is present on my left, and something is present on my right present and left present. So something is present on its left, something is present on its right. That means this is the point where these two are separating their ways, and this is the lowest common ancestor. That means the lowest point which is common for both of them. Okay, lowest node which is common for both of them, it is the point where they are intersecting. Okay, so this is my LCA. So I hope you got this dry run, and from here you will simply, as you return two true, so you will simply return true, true, true from this. Okay, so now let us go to write the code. Okay, I hope it is clear. So now we'll write the code. So let us now look into the code of it. Okay, so we are going to code in CPP, right? So C++, and so first of all, I told you that we are going to take a global variable, right? So we'll take a global variable, that is tree node star, and we'll name it LCA node. LCA node, or let us say LCA. Let us say LCA is equals to null PTR initially. Okay, and after that we need to make a bool function, right? Bool LCA helper. Let us say LCA helper, and we'll pass a tree node root comma int p comma int q. Okay, so these are the three things that will pass. And first of all, if my root is null, right, root is equals to null PTR, then at that point we should return false. Okay, because from here we haven't got anything, so we should return false. And after that, if my root dot val, okay, if my root val is equals to p, or root val is equals to q, then at this point what I should return, I should return true, right? I should return true that I got a value. That means my, okay, I need to make let us say bool sd is equals to false, bool self done, it is self done, and we have a self present. Let us say self present, sp is equals to false, lp is equals to false, and then we have bool rp is equals to false. Okay, these three things. And after that, suppose if my root val is equals to p or q, then at that point what I should return, I should return no, I should not return anything. I just simply will write sp is equals to true, right? My self present is true, should not return anything, just write sp is true. And then after that what I'll do, I'll make a left call, that is LCA helper for left. Okay, one more thing, I should write here LP, left present, is equals to LCA helper for left, and we'll write here root dot left and p and q. Okay, and now let us write the same for right. So same thing for right, that is right present root dot right. Okay, root, it is root dot right. it is root dot right, and we have a p and we have a q. Okay, it is root dot left pq, root dot right pq. Okay, and then after that what I should return, I should return, see, from here I'll get some bool values, right? My left present, my right present, and self present. I should return if any one of true. That means my sp is true, or my left present is true, or my right present is true. If any one of them is true, I should return true, right? So I will return or, I'll return or conditions for all three. And one more thing, that is if my, see, two checks will be done, right? First one is if sp is true, and then lp is true, or if my sp is true and my right present is also true, or if my sp is true and my see, sp right present, okay, it is if my left present is true and my right present is also true. So in this case I should set my lca, right? lca is equals to root val, I mean root, okay, because it is our tree node, right? So lca is equals to root, and we should return true from this point because we got our lca, so we should not travel anymore. Okay, now anything else? Yes, the else thing is, if suppose if I'm saying my left pair, not left pair, if I'm saying my lca is not equals to null ptr, that means I got my lca, right? I got my lca. So when I got my lca, I should simply return true without doing anything. I should simply return true. Same from here. Why would I travel the whole tree if I am getting my lca at some point? So if my lca is not equal to null pointer, then I should return true. Okay, I should return true. And at any point, if I'm getting two true, that means my left present is saying I'm also true, my left and my self present is saying I'm also true, or same with right present self present, or same with left present right present. Then at that point I should set my lca and should return true, right? Okay, it will be not dot, it will be arrow. Same for this and anything else. I hope that's it. So from here we should call lca helper, right? And in that we should pass root pq, we should pass root comma p comma q. Okay, and after that we should return what you should return, we should return lca, right? lca, okay, we should return lca. So it is the code that we have to write, and let us give it a run to check if it is running correctly or not. Code is running correctly. Let us give it a final submit for all the test cases. Awesome, completely accepted. So I hope that you got this question completely. Okay, in this we haven't used any extra space, we haven't used any node to root path, okay, function, we haven't used anything apart from recursion. Okay, so this is a good way of doing lca, okay, of finding lca. So I hope that, okay, one more thing, some will say, okay, why you are using a global variable, why not without help of global variable? So you can also do that. See how you can do that. You can change this to a node type, right? To a tree node type. When you will change this to a tree node type, then you have to set the conditions so that you can check if the left side that is returning, if something is returning from left is not equal to null pointer, and something that is returning from the right is not equal to null pointer. Okay, if I'm returning, see, when I'm not getting anything, I should return null, right? When my node value is not equals to the node which I want to find, I should return null pointer. And when my left side is saying that, okay, my something returning from my left is not equal to null, something returning from the right is not equal to null, then at that point I will say, okay, something is returning from left, something is returning from right, so I am the point where they both are intersecting. Okay, so this is how you can do it without help of any global variable. Okay, so I hope you will try this by your own. Okay, and you will try to make video on that also. Okay, so after that we'll meet in the next video. Okay, so till then, goodbye, take care, and also don't forget to like the video and subscribe our channel also. Goodbye.